A very, very important concept is the multi-threading. Is a very important and very efficient way to perform the operations. Multi-threading, threading. So that means the best example is the I think you are sending the message email. While you are typing the email, then along with the email you are typing, then if you are wrongly spelling or wrongly spelled the any word, then it will give the red color. It will give the red color. But according to your point of view, you want to send the message. But inherently, inherently, the system can perform another work simultaneously, concurrently, or simultaneously can perform another work, another task. What is that task? Whether you are wrong spelled, then it will give the indication. Okay, or the grammatical error, it will give the some error. So recently one is there that is called as a Grammarly. Is the recently developed with the Grammarly. So while you are typing, then it will give any error, then it will give the, or any grammar problem or the grammar error, it will give the indication. That is called as a best example of the multi-threading. Okay, right. So I repeat, the multi-threading stands for multiple threading. So that means more than one thread can be executed in the program is called as a multi-thread. Multi-thread. So that means one thread can perform one task, another thread can perform another task. Both are executed simultaneously or concurrently. So within a single program, multiple tasks should be performed by using the multi-threading. Simply you can understand a single thread can perform single task. Multi-thread can perform more than one task, but all the threads are included in a single program. In a single program, that is called as a multi-threading. So it is already. And second one, the best example for the multi threading is that you are watching the one movie in the YouTube. While you are watching, you are contacting with your friend. Okay, so that's why using the same device, you are performing the multiple tasks. One is watching, one is sending the text, one is the listening the audio. So all is the best. While you are typing, a internal task is to find out the what errors. Ordering keyboard entering is one task, and next one, whether grammar spelling is the called as a multi-threading. Simply say that a thread can perform a single task. Multi-thread stands for multiple tasks should be performed. To perform any task, it requires a program. So that's why it is a set of instruction to performing a task. Performing a task. But all the tasks are included in a single program. Single program. So that's why multi-threading stands for multiple threads or multiple tasks can be executed or concurrently by using a single program. Single program. Okay, so this is called as a multi-threading. So let us take what is the multi-threading. Multi-threading refers to two or more threads executing concurrently in a single program. Okay, all right. Right. So this is called as a multi-threading. I am explaining the present theme. Later on, we should go and in detail about the programming. So don't worry. Okay, right. Where you are finding that. So in the Java inbuilt class is there. What is the class? So this is already explained in the previous class. Java is a package dot lang. Lang is a subpackage dot. Within the subpackage, package is a class. So that's why. So within the subclass, thread class is there. So that thread is a inbuilt package, inbuilt class. We already discussed with you. Package is nothing but a collection of classes. Suppose if there is a subpackage, then to accept the subpackage, the main package dot subpackage. So what is the subpackage? Package is also a package which contains the classes. So that's to access specific class, then dot you can use the threadings. So this is inbuilt class Java. Right. So the idea that program can perform the multiple task. Each and every task should be is called as a program. That program is advantage by using the multitasking of the multi. So that I want to explain what is the advantage. Advantage of them. Suppose multitasking be performed by using the two ways. One is called as a multi-threading, another is called as a multi-processing. So here the thread, there is a process. So process and the thread both are performing the task. So task is nothing but one type of program. Program is nothing but a set of instruction. So simply a task. So for the task execution, we should write the program. So that's why this is called as a multi-processing. This is called as a multi. What is the main advantage and disadvantages? What is the difference between the multi-processing and multi-threading? Multi-processing stands for all the programs are independently available and are executed parallelly. Executed parallelly. Okay, parallelly. For each and every process, we can allocate a specific memory location. A specific memory location. N processes are there. Then N uh, n memory spaces are allocated, executed. So time is saving is that a memory space can be occupied n programs, n memory spaces. So at present you are using the iCore 7 series. Okay, quad core. Quad core stands for 4 processor uses. Octal core, 8 processor uses. So that means 8 process stands for 8 processor. Each processor can perform a specific task. Then parallelly 8 programs are executed. That is called as a multi-processing system. Okay. So here what is the advantage? Parallelly all the programs are executed. But what is the and time is very consumed. The time is saved. But the main drawback is memory space will require more. Each and every process requires a separate memory, a separate memory. This is the main problem. But what is the disadvantages? Suppose one process to another process. Already mentioned that process stands for program. Okay, so it is a can perform one task, another program can perform certain task. So to suppose sometimes that output of the one process is required by the another process. In this situation, it is somewhat difficult to access or communicate between the two processes. It is a somewhat difficult. Somewhat that's why it is called as a heavy weighted tasking. It is called as a heavy weighted tasking in which and the multi-processing. Okay, multi-processing. So the communication between the process to process is somewhat difficult. Okay, so it is called as a heavy weight task. So here, now I want to discuss about the multi-threading. Why we are using the multi-threading? So number one, we are using single program. We are using single program. So whenever you are using the single program, a single memory space is required. By using the memory management unit, we should efficiently utilize the memory. I repeat, by using the memory management unit, we are efficiently using the memory. But one program, one memory is available. First part, one program, one memory is available. Next, but you can raise it out. Sir, you are saying that it can perform multiple tasks. So actually, all the threads are included in a single program. All the threads are included in a single program. Okay, so that's why memory space is uh, utilized properly. So that means less memory space for more multitasking. First point. Second point, normally if you are using a single program, maximum most of the time the CPU is in ideally or idle because it can wait for the response from the IO devices. But processing takes very fast, but accessing the data from the devices will take longer time. So that's why CPU maximum trying to access the data from the IO devices so it can be keep in ideal condition. Okay, one revolution and one technical aspect is that why should we not use, why should we keep the processor or the CPU in ideally? Why you are not utilizing that time? Why you are not providing a work to the CPU? That is the efficient utilization of the CPU time is a very important. Then the new concept comes into the picture that is called as a multi-threading. Multi-threading stands for multiple programs are there. So that's why suppose while one program is allowed to continue running, then the CPU can continue executing another program, another thread, another thread. So while the at a time once a thread is selected, that can be executed by the CPU. While completing the one thread, then it is next going to the another thread, continuous, simultaneously. So that's why the CPU is not in idle. So it is utilizing properly. It is always busy. Once it is always busy, then the multitasking are performed simultaneously. That is a main concept, main funda. Number one, less memory space. Number two, you are keeping the CPU in ideal, not in ideal condition. It should always keep the busy. So that is the main advantage in the multi-threading. How and what I can explain later, but you can understand the concept. You can understand the concept. Okay, so what is the main advantage? To utilize single memory space and you can keep the CPU always busy. So here I am saying that multiple tasking. So the tasking is called as a thread. Multiple threads are there. Once a thread is selected, then that can be executed by the CPU. While it is ending, then second task is allotted, third task is allotted simultaneously. So that's why it is keeping in continuously busy. So that's why efficient usage of the CPU. So time is saved. That is fast. When multiple more tasks are performed in a less time. Second thing, memory space is utilized. This is the efficient utilization. That is the main advantage of the multi-threading. Okay, right, right. So so next is the life cycle of the thread. Okay, single thread. So normally, if you are utilizing the multi-threading, one minimum thread is executed that is called as a main thread. That is called as a main thread. Normally, this main thread can be executed last. Suppose there are 5 threads are there. So within the 5 threads, one is the main thread and remaining is the 4 child threads. So this main thread can be executed lastly. So because the allocation of the devices or IO devices allocation should be take place once all the tasks are completed, then finally the main thread is working. Okay, so but so many people thinking that main thread can be performed first, remaining will be last. That's not. So main thread can be performed last after allocation of all the allocations, all the devices to the thread. Finally, it should be executed. So this is the one important. So what are the stages of the thread? What are the stages of the thread? So I repeat, thread is a program. Program can perform one task. Okay, so that's why to perform one task we require a program. That program is nothing but so a thread. So what are the different stages of the thread? That is called as a life cycle of the thread. Life cycle. So actually, let us take example of ours. Um, because first one we should be generated, so new one, so a new baby is generated. So after new baby is generated, then it is thinking, as goes on, then it is thinking, so it is completing. So once it is thinking, then it can be practice. Once it is practicing, then it is thinking and you want to do certain things. Once at the end of the stage you are completing and you are retiring from the job. So this is called as a one cycle. Okay. So a cycle stands for generation, initialization, runnable, and running, and dead. This is the five stages of the human cycle. Same way, the thread also having the five steps are there: generation, creation, runnable, running, and dead. So dead state. Okay. So these are all the sequential steps. These are all the sequential steps. Once a thread is created, it can perform the five steps called as a. So from the creation to from the closing, that is called as a threading, is called as a life cycle of what? Thread. Okay. So now we are explaining in detail what are the steps are there. The first one is called as a. This is called as a new thread creation. Okay, new thread creation. By using the, you are creating one new thread. Second step, creation of the thread is not, it is important, but after creation of the thread, it is not implement itself. It is not implement itself. Once you are initiating the thread, then it can start working. Until otherwise, it is only in the creation stage. Okay, so that is called as a new thread state. That is called as a new thread state. So that means creation of the thread is the first step. Creation of the thread is the first step. So now you can running the thread state. What are the steps? You can initiate. You can initiate the thread. So that is called as a runnable state. Runnable state. So before the start of thread method of the thread, it is in the creating stage. Once you are indicating, allocating a start, then that the thread starts running. So that is entered into the runnable state. That is entered into the runnable state. So that's why creation of the thread. So that can be creation of the thread before the start. Once a start method is implementing, then that method or that thread is entered into the runnable state. Runnable state. So while it is running, okay, after start, then it is entered into the runnable state. So then it can start creation, it can performing, or it is processing. So while it is a processing, there are two stages are there. Number one, sometime to process or to running this thread, it is required another thread output. Another thread output is input of the present thread, certain times. Certain time. So at that moment, that runnable stage or runnable thread is into waiting stage. Waiting stage. Normally, it may or may not be. So suppose there is a no independence. There is no independence. Sorry, there is a independence that indicates every thread having its own work. So then what happens? Creation, runnable state, running, and executed. No waiting. No waiting because it is independent. Independent stands for it is not depends upon the other thread outputs. But normally it is not possible. Sometimes it may be useful you the output of the one thread is the input of the another thread. At that situation, creation, start. Once you are starting, then it is entered runnable. Once it is entered runnable, it is the running. But it can be wait for certain time. It can be wait for the certain time. So if it is waiting for the certain time, then it is entered into the wait stage. That thread is entered into the wait stage. Then the scheduler can allocate another thread to the CPU. So that is the main advantage. That is the main funda. That is the main task in the multi-threading. While one thread is entered into the wait stage, then CPU is free. So I don't want to keep the CPU free. So then immediately scheduler can allocate another thread to the CPU. So while it is running, then it can perform the previous thread can perform the task. So then again come back. Again come back. So within this time, another thread is completing. So that's why two threads are simultaneously completing the task. Okay, that is called as run. Once a running is completed, that is processing is over, you will getting the output. So then what happens? Its task is over. So once its task is over, then it is entered into the ending stage. That is called as a dead stage. What is the dead stage? To finishing the processing is called as a dead stage. Okay, so creation. Any problem? Banu? Banu, any problem?
No, sir.
Okay, now. Okay. Now. So please maintain the discipline. Okay, right. So creation, then start, entering into the runnable by the start, then it is performing the running. While the running, it is independent, then it is finishing the task and then enter into the ending stage. That is called dead stage. Second time, it is running, then it is waiting for the output of the another method, another thread. So that's why it is entered into the wait stage. Okay, I can show you one diagram. It is already shown, but I want to discuss. I want to show that. Yeah. Okay. All of you see that this is the life cycle of the thread. This is the life cycle of the thread. So this is the creation. After creation, you can start. Then it is entered runnable, and once it is a, you can overloading of the run method. Then it is entered into the running. Okay. So here there are two stages are there. One is called as a waiting. Another is called as the end of execution. So if there is no, if it is independent, then it is directly entered into the end of the execution. Suppose if it is dependent or sometime it will require more time for the execution, it will enter into the sleep mode. So that is called the wait mode or sleep mode. So then it can wait certain time. After certain time, it is again finishing the execution and it is come out of the dead stage. So this is called as a life cycle of the thread. This is the life cycle of the thread. Okay. Now, okay, that's I'm saying that how to create a new thread. This is available in the java.lang.thread class. It is a thread class. So actually, there are two types to create a threads. Okay, there are two ways to create the threads. One is called as a by using the thread class. By using the thread class. Second is by using the runnable interface. Runnable interface. Okay, I can explain that. So to create a thread, we are using two types of method. One is called as a thread class, and the second one is called as a runnable interface. Okay, that should be discussed later, but not right now. Okay, next one. So here, what I'm saying in previous one, once you start it, then it is entered the runnable. Once it is runnable, then if you give the instruction to run, then it is entered the running state. It is the running state. So by using the run method, it is entered into the running state. So after running state, two stages. One is the wait stage, or another one is the sleeping. That is the dead stage. So this already discussed in the previous one. This is the runnable stage, not runnable state. So once it is created the run, then already saying that there are three stages are there. One is sleep mode. Suppose certain it will be wait. It can be wait for certain time. Then it is entered into the sleep mode for the 1000 milliseconds or 1000 microseconds. So there is a certain time it should be well. Then you can use the sleep method. You can use the sleep method. Sometimes if you are entering into the continuous loop or continuously you are not closing your program, then I want to suspend your thread. So that means you can enter into the suspend method. So that means you may be suspended. So who and why and how, I can explain that. Second type, it is also wait. So waiting for the another one, waiting for the another output of the thread. So that means you can use the wait. So these three stages are called as a not runnable. So runnable and not runnable. So that means it can be entered into the wait stage. So the thread is blocking an IO and waits for its completion. So normally in the IO devices are slow devices than the CPU. IO devices, what are the IO devices? Keyboard, mouse, printer, and scanner, and display. These are all the slow devices. These are all the very slow devices. CPU is a very fast, okay? So that's why to communicate between these two, it will take some time delay. So that time delay is called as a sleep mode or it is a waiting mode. It is called as a waiting mode. So these stages in the thread is called as a not runnable. So this is a that is already explained. Right. In previous, I am saying that a single program contains the multiple threads. It is right. But which thread can perform first? Who can perform first? Okay, so that a device or a program is called as a scheduler. Scheduler. This is the operating system can select the scheduler. Scheduler. Okay, scheduler select the a particular thread in the multi-threads. Once a scheduler select a thread, that thread task should be completed by the process or processor. I repeat, scheduler is a process which can select a specific thread. Once it is selected a thread, then that thread task should be completed by the CPU, because single CPU is there. Single CPU is there. I don't want to keep the CPU ideally. So that's why, suppose a thread is selected, that thread can be executed by the CPU. So CPU execute only the scheduler select a particular thread. Okay, so what is the mechanism to find out the thread, to selection of the thread? There are two main methods are there. So there are two categories. Number one, preemptively. Okay, preemptively. Second one is called as a time slicing. Preemptively and time slicing. What is the preemptively? What is the time slicing? Time slicing stands for, according to this process, every thread is equal. Every thread is equal. But in a program, there are multiple threads are there. To select a particular thread, what is the method? Time slicing method is there. What is the time slicing? According to your threads, the time should be divided. That division of the time is called as a time slot. So suppose five threads are there, then the execution time can be divided into five parts. Five parts. So first part, that is the 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. Okay. Okay. So first 1 by 5 time is allocated to first thread. Once a time is allocated to a particular thread, it can, that depends upon the task execution, whether it is a within the time slot, it is a less time, it can complete the time. Okay, it's a task. So once it is task, then it is not go for another one. It is wait for the next time slot. So that means I can allocate a specific time slot to a particular thread. Then the thread is selected. So the thread execution can be performed by the CPU. Okay, within the time. Suppose if the time is still available, it cannot perform. It cannot perform. Now 1 by time slot is over. So go for the next time slot. The next time slot go for the next thread, but not the previous thread. Okay, there are two chances. Number one, once a time slot is allocated within the specified time, it can be completed its action or performance. Suppose if the time is not sufficient, then it can be wait. It can be wait until the next time slot is allocated. Next time slot is allocated. Okay, so once the time slot is over, go for the next. So next thread comes into the picture, then it can be executed. So next and next. By this way, once the five slots are over, then again the first thread comes into the picture. The slot is allocated to first thread. This method is called as a round robin method. Round robin method. In the round robin method, each and every thread having a highest priority. So consider as a each thread as a highest priority. Once it is the highest priority, that can be selected and that can be executed by the CPU. So here, what you can understand two ways. Number one, each and every thread having a highest priority, or number three, selection. So once a time slot is allocated, then it can be wait until the next slot is allocated in the round robin method. In the round robin method. So that's why once a time is it can executing within the specified time. So this is called as a time slicing scheduler. This is called as a time slicing scheduler. Second one is a preemptive scheduler. Preemptive scheduler stands for all the threads are not equal. All the threads are not equal. They are not having the equal priority. Some threads are urgent, some tasks are urgent, some tasks are okay. It is not as urgent as the previous one. So that's why certain tasks are important, certain tasks are it is not urgent. So that's why As the urgency decreases, its priority level decreases. Its priority level decreases. Or you can allocate the priority to the scheduler, that is called as a thread. Okay, so now what happened? All the threads are not equal. Each thread having a priority, but the priority is not equal. So once which priority thread can be executed, that means which are having the highest priority of the thread, that can be selected first. That can be selected and that task should be completed. While the highest priority thread is comes into the picture, it cannot be executed. It should be waited. Then it is entered into the wait stage. Then it is entered into the wait stage. So that's why I'm saying that. So in the preemptive method point of view, first a highest priority thread is selected. Once it is selected, that is in the running stage, then that task should be completed by the CPU. Suppose it is taking long time. So while a highest priority running executing, then another thread is executing, then it is not executed. It should be wait. Then immediately it enters the wait stage. Okay, this is the first part. Second point, suppose present lowest priority thread is working. I repeat, lowest priority thread is working. That is, it is in process. While it is in process, highest priority thread comes into the picture. Then lowest priority thread can be stopped temporarily and it is entered into the wait stage or sleep mode. So highest priority thread is give the preference to the highest priority. Give the highest priority. So that means in the preemptive scheduler, always prefer the chance to highest priority thread. So the thread priority should be allocated, okay, by using this is called as a get priority and set priority, get priority. Set priority means you want to set the priority and get priority. What is the present priority of the thread is running? So you can find out. So get and set priority. So normally there are 0 to 10 priority levels are there. Default is the 5, lowest is the 0, highest is the 10. So you should be understand while the lowest priority thread is working, at that moment highest priority thread is selected, then lowest priority thread enter into the wait stage and highest priority thread is executing. After finishing, then it is come back. Okay, so this is the process. While highest priority thread is working, no lowest priority thread is not entered. It should be entered into the wait state. Always lowest priority thread enter into the wait state or sleeping mode while the highest priority thread comes into picture. Okay, right. So that's why I'm saying the scheduler, the thread scheduler, preemptive scheduling, time slicing. This is my yielding. There is another property. So yielding stands for uh, you should allocate equal priority to the thread. Suppose two threads are there. One is the highest priority, second one is the lowest priority. So to make the another thread as a equal priority, we can use yielding. We can use yielding. By using the yielding, the priority levels of the two threads should make the equal. To make the equal. This is called as a yielding. Okay, right. Now its time is over. Okay, sorry. So next class is already waiting. So I'm stop this class here. Thank you. If you have any doubt, so please send your queries to my personal WhatsApp. Thank you.